Howdy, everybody. Hope you're doing well wherever, whenever you are. We're here for day 18 of Advent of Code 2016. We're making progress. Just as like an intro, I also found another. So there is that Everybody Codes. It might be fun for y'all to check that out if you're into programming. I like partially solved one just to see kind of how it works. So if you're interested in that, we can do those. But then I also found this Caddis one. It's more geared towards like practicing competitive programming things. Anyway, I'll include the links in there if you want to check them out, and maybe we'll do some of those puzzles after. So there you have it. Okay, with that, I think let's just get on to the day. This one is Like a Rogue. As you enter this room, you hear a loud click. Some of the tiles in the floor here seem to be pressure plates for traps, and the trap you just triggered has run out of water. Oh, run out of whatever it tried to do to you. You doubt you'll be so lucky next time. Upon closer examination, the traps and safe tiles in this room seem to follow a pattern. The tiles are arranged in rows that are all the same width. You take note of the safe tiles, dots, and the traps, carrots, in the first row, your puzzle input. The type of tile, trapped or safe, in each row is based on the types of the tiles in the same position. The type of tile, trapped or safe, in each row is based on the types of tiles in the same position and to either side of that position in the previous row. If either side is off either end of the row, it counts as safe because there isn't a trap embedded in the wall. For example, suppose you know the first row is and want to determine the next row with tiles marked by numbers 1, 2, 3, 4, 5. The type of tile 2 is based on the types of tiles A, B, C. The type of tile 5 is based on D, E, and an imaginary safe tile. Let's call these three tiles from the previous row the left, center, and right tiles, respectively. Then, can you guys hear the wind blowing? Then a new tile is a trap only in one of the following situations. I might try and fix that really quick. Hold on a second. Okay, sorry. This time of year, I really like the wind. And, well, not necessarily the wind, but the cool weather that I can open my windows. So, okay. Where were we? Okay, so if the left and center tiles are trapped, but its right is not, then it's a trap. If its center and right tiles are traps, but its left tile is not, then it's a trap. Only its left is a trap, only its right is a trap. Okay. In any other situation, the new tile is safe. Then starting with this row, you can determine the next row by applying the following rules. So this one would be between three safes. Because they're all safe. The first tile's safe. The second character consults these three. And we got only the right, so it's a trap. The third character looks at these three, and it's a trap. The fourth character looks at these three, it's a trap. And the fifth looks at these two plus a safe, which is a trap. Okay. After these, you get this. And then if you do it over and over again, you get this. And then like here's the output. Then they give you a larger example. In 10 rows, this large example has 38 safe tiles. starting with the map in your puzzle input. In a total of 40 rows, including the starting row, how many safe tiles are there? And then here's my puzzle input, which is larger than the test, but not substantially larger. Okay. So there you go. For part, I mean, I think we can just, for now, we can just maybe just follow the rules naively and see if we need to do anything. These look like potential bitwise operators. So if we have to optimize, we could probably turn this into a bit or like a number and then do bitwise operations and count ones. But I think for now we can, but let's just start with the tiles. So maybe we should have some tests too. So let's get started. Okay, our input is just going to be a string. And we're just gonna trim it, right? Oh, we could make it a vec car. Do we want to do that? Sure. Okay. Should we write some test functions? Just to be sure. My thing doesn't seem to be working. My LSP? I don't know why that is. So if we start with this, we expect 38. What if I do this? Does that? There we go. Okay. Overlay, use this. Okay. Did I update my watch command to something like that? Let's see if that watch works for now. So we're going to do it in our test case. We're going to do it 10 times. So we do like let count equals 0. It's going to have to be mutable. And we'll return count for in 0.10. Oh, input dot iter dot filter c equal, we're counting traps, right? No safe tiles, so we're looking for dots. Enter noise. Interesting. Have to double it. Okay. So now we just need to do the like we can have an fn next function. So you give me an input, and I'll give you an input. We can just do the first and the last. And then we could do so it could be like what I'm thinking is we could do like once dot chain input dot iter dot chain like that dot window what doesn't it like? Oh, I need to do another once here. It wants me to have lifetimes because okay. Is chain not what I'm wanting? No, it is. Take two iterators and create a new iterator over both sequence. Like, I'm pretty sure that's what I want. So I must just be doing something right here. Expected car found. So do iter dot. And do like cloned. dot windows. I don't want return iterator. Oh, can I do tuple windows of 3? Looks like I can. I do like that. Dot map like LMR like that. So now I have my left, middle, right. And I think I just want to go if left and center are traps, but its right tile is not. It's center and right. Only left, only right. That's saying left, center, left, only left, only right. Only left, only. I think this is an XOR of left and right, right? It's saying the center doesn't matter. These ones that is like the center doesn't matter and only left or only right. This one is left and center, but not right. Center and right, but not left. So it's an XOR of left and right. Kind of. It becomes a trap only if one is not. So I think, yeah, we can just do, for now, let's just return this. See if that works. Oops. Oh, I can't do this. Okay. That's kind of cool that it can figure out because of my map that it wants to be this. So I actually don't care about the middle. I can just do match LR. And if it's like this or and this, we return this, and then the other way around. Caret else return dot. Okay. So we just do think that's saying my test failed. Left 40, right 38. Am I doing this wrong? If left, then a new tile is a trap only in the following. Left is a trap, right is not. Right is a trap, left is not. I mean, I guess I can do all the rules. I'm almost positive right? The center doesn't matter. Like it's a trap if left and center but not right, right and center but not left, left only, right only. Like these rules essentially are saying left but not right, or right but not left. So that. Like those are the rules, I think, right? Still get 40. Something happening with this once chain thing. Oh, I think I did too much. No, I want to do it. Yeah, it is too much, huh? No, don't do it that many times. Yikes, that was almost trouble. Okay, there you go. I had done it too many times. Okay, so now we actually want to do it 40 times. But we already have our own. So do that. Presumably that's our right number. That is the right answer. Okay, always feels good when you submit it once and it works the first time. Of course, after fixing a couple defects, right? Part 2. How many safe tiles in a total of 400,000? Okay. I still think this will probably finish in time. Like 202 milliseconds? Okay. That's the right answer. Okay, I don't know what to say. I mean, I this day wasn't too bad, right? You did have to figure out some logic. I can probably go back to the way I originally had it, huh? So it was just 2 rules, and I was really only interested in this and this. Yes, I get the right answer. The problem is I miscounted. So I could probably write a helper function to do this. solve and just say how many times. So fn do I need these lifetimes? Yeah, it doesn't like them without. Okay, so if we do fn next n, where you give me an input, and I give you a u size, u size, and then we just do this. Oh, I should ask for n. Like that. Okay. Not too shabby. So I do kind of want to. I mean, this is still really fast. Do we just leave it here? Or do we try and do like the integer thing? How long is it? 100? Like it's 100 bits. So you could potentially. You'd have to store it in like a U128. Isn't there a bit set thing? How do I share this? Create bit set. Underlying for holding unsigned numerical elements. I actually don't think this is the same thing. It's a set of unsigned integers. You could ask The XOR part is probably not bad because you just shift XOR. Oh, I can just turn it into ones. Oh, that's true. I can have an accumulator and I just shift turn it into ones. And then shift 1 3, shift 1 5. Using bitvec for arbitrary length. Maybe bitvec is what I was thinking of. I'm more inclined. I kind of just want to do this right here. I think. And then I can do these XORs. So let's just try that. Is my thing still showing up? Okay. Okay. I want to turn so there's 100 bits. I had to use like a U128 or something like that. So we go, I was just thinking like how many I need to use. So let bits equal input dot iter dot hold, right? We're going to start at 0. U128. And then we're going to have an accumulator and a character. And we're going to say if car equal, no, if C equal wrap, we'll return, or we'll do how did they do that? Oh, we want to go, we want to shift ACK first. ACK shift 1 or 1 else 0 is how it did it. I have an extra thing here. Is that right? So bits. Like that. Oh, I have to. Okay. Oh, it's a U32. I guess it will never be. No, each one could be a U32. I mean, we know the number's small, but we'll do this. So then we still do we'll do bits. Still do this. We'll do bits equals next bits, and then count plus equals bits dot count ones as usize. So then this one right here is where we got to do our work. Ooh, do I want to keep both of these solutions? I think I do. Just so you can see how they both work. Bugger. Like that. So that's my original solution. So now we'll do fn next in bits. For in 0.n minus 1. Yeah, like that. And we just got to implement next bits. You give me in U28 or U128. I'll give you a U128. Okay. Oh, it's not n, it's bits. Okay. So like for each one, we want to know what n is, right? So n usize. Because we're going to want to shift and do the thing. So it looks like this. Oh, it didn't show me how to do it. Let's try this. I have a U128. How can I XOR the third and fifth bits? X XOR the third and fifth. So we need to just do, we'll need to do the first. So like the first one is always just going to be, actually we want to do it backwards, huh? No, we do want to do the last bit. So we want to do like a let next equal 0. And then we do, actually we can do it right here. 0. Let's see. I want to set the value of a new U128 at bit 4 to the values of bits 3 and 5 in the previous value. Okay. We'll use this. I think you can do it in one line. So we say for I in, we want to do the first one in front of the for loop. So that's going to be the 40th bit. And so we want to just check if the 39th is on. So it would be let the only way the first one can be set is if it's on. So it'd be like next. Oops, what was I doing? Next or equals this, right? So it's going to be 0. I'm going to shift input 40. And by 1, and that only works if the last one is correct. And then I'm going to OR it to next. So this should have the effect of turning it on or off, right? This bit stuff sometimes, I haven't done this stuff in so long. What is it saying I don't need to do here? Oh, it is going to shift before subtraction. So input. So I take the input, shift to n minus 1. That'll get me 39. The 39th bit, right? And then I AND it by 1. So I clear everything in front of it. So now I only have a single bit set or not set. And I OR that to next. Okay, I think that's right. And then I want to do it at the end with the very last bit. So I actually think it's just input and 1. Oh no, it's going to be the previous bit. So it's gonna it is gonna be shift 1. So that's gonna get me this, the far side and the other side. And now I can do my traversals. So I can be like a 4 in or I in. I think I need to do 1, right? Because I don't. So I'm going to do I plus 1. XORed with oh yeah. What are the chances this worked? Is it slower? Am I really that bad at this? I mean, I don't get the right answer. So let's try and just do part 1. Does feel like it's faster, but why didn't that one work? Why doesn't part 2 work? Okay, let's see. I'm pretty sure this part is right. So it's just these, right? This right here. Take the input, shift it 39. Here's what it says to do. So maybe I can just compare this. I was kind of looking at it and trying to do it. So the first time I want to shift it 39. Because I want to get like the 40th. Think about it. If my how do I say this? If my length is 100, right? The very end, I want to, or like to build the first character of the next one, I want to consult the 99th character, and I only care if it's turned on or not, because the other one is always turned off. So if it's turned on, then it will, the 100th character will be a trap. So I want to shift 99 and 1. I think that's right. And then this is going to go from 99 to 1. Right? And it's going to say, get me the 100th. Do the same thing with the 100th. XOR the 98th. Okay. That doesn't seem wrong. I'm going to XOR these two, and it's going to return a 0 and a 1. Oh, I need to shift. I need to do next equals next 1. We're getting closer. I guess we could ask AI here. Let's see. Do this, and we go pilot. Yes. At solutions AOC 2016 Surspin. Day 18 RS. Why doesn't the next n bits work? Like next n? I'm essentially trying to XOR the left and right bits of the previous input. Okay, while it's thinking, I guess I could combine these lines. I can say you can see it definitely is doing it faster. If it ever does it right. Oh, this is not N. No, it is N. It's like, okay, let's see. Yeah, I think it is 1 to N. Reversed. Because this is gonna, so I want to end up with N bits set, right? Oh, it's not N. It is not N. That's my problem. Okay, I don't know what this thing's doing. It's the lane of input. That's feeling much closer. So we know it's length 100. We shift 99 and 1. And we do that because we only turn that one on if the 99 bit is turned on. And then we're going to go from 99 to 1. So like this starts at 1, presumably, or whatever. first one is. It might be worthwhile to print these out. Next, NBIDIs. Left is 66. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so for the test, in next NBits, let's print them. It would be bits. Shift. K minus I. And 1. So if that's true, we do a trap. Else, we do a dot. Oh, so if this equals 1, do this, and then we'll do it in here as well. It's probably gonna spit out a bunch of stuff here, but let's do it for the test case. Double dots. I am off. Why is that off? I start at 0. I actually want to shift No, this is right. I shift 1. I start at 0. I shift 1, doesn't matter. Or it with C equals that 0 or 1. What is my input? It is a single dot. Is my math wrong here? I can just do I rev like that. Does that maybe change it? Yeah, it does. Okay, so the first one is definitely right. Oh, but I gotta do it down here as well. Okay. Ooh, this first bit has issues. It's the first bit that has issues. So what is that? Oh, this is, it should be Shift K. Right? No. It feels like the inner ones are actually good. Like I'm just scanning. The inside ones are definitely good. So I feel like what's happening right here is correct. Oh, I'm supposed to be counting safe tiles. I'm such an idiot. Even worse. Oh, I have all of the zeros at the beginning of the 128 bits. So it's like, so we should do FN count zeros. Input U 128 K U size view size, and it's going to be I guess I can just do this while or like I kind of want to, can't I just do this with the input? So if I do do this, and then I just say if input and 1 equals 0, count plus equals 1, input shift 1, that, oh, and then I return count. I need to do shift equals 1. Oh no, it's bits. Okay, we got there. So maybe remove these print lines and see. Definitely a sign I need to work on my. Okay, so why does this one fail? Or I guess it doesn't. Okay. So like what is all this saying? Was it worth 40 minutes? Maybe not. Yeah, I mean, if you're just trying to solve the problem, how much time did I save myself? It like more than halved it. I think if I was better at the bitwise or the bit manipulation stuff, it's just been so long. Is that a proper excuse? I should just get better at it. These things used to make a ton of sense. I don't know if I've told you before, but I used to do a lot of work in C, and we would do things like this for hashing and stuff like that. Yeah, like, is it better, faster? I mean, it's definitely faster. Is it better? I don't know. This seems more readable. You could probably make this more readable. So just to be clear, like what's happening here is these operations, like if you like whittle down what it actually looks like, you discover that the center tile doesn't actually matter. You're just looking at the left tile and the right tile, and you're only interested if it only becomes a trap if exactly one of them are a trap. and that in bit manipulation is an XOR. So it does. That's what led me down the path. I'm like, oh, this looks like it's an XOR. So we solved it the normal way, and that took how long? 18 minutes, which again, I could probably improve time-wise on that. And then part 2 was just, instead of doing it 40 times, do it 400,000 times or something like that. Took less than a minute to solve, right? We've now spent almost a whole hour doing the bit version, and admittedly, that hour is my ineptitude, because the total number of lines, right, is 22. It turned out to only be 22 lines, but it took me 50 minutes to write those 22 lines. And again, that was, it's more than that, huh? It's like 35 lines or something like that. But still, just me not being familiar with the bitwise operators. So this is definitely a place I could improve, especially when you're looking to like solve something that's performant. But like what exactly is happening? The way to think about it is, from the previous one, you're really only interested in the one to the left of it or the right of it. And if you're at the ends, then you're really only interested in the one that's like inside of the array. So that's what this first one says. Oh, I just need to check the kth item. I actually think this is not right, isn't it? Is it just because of my... Yeah, I think it's the k-1 item. I'm only interested, if I want to know what the 100th item is, I'm only interested in the 99th item, because the 101 item is always turned off. So I just need to know if that one is turned on. And that's what this has the effect of doing. Basically, we shift 99, so we move the whole thing over to that 99th bit, and then we AND it with 1, which means it's only going to turn on if this one is 1, right? So you imagine this one is a bunch of zeros with ones. We AND it, we get that. So this is something to remember, is like, oh, I want to get the nth bit or whatever. I need to remember this. But I mean, this is obvious in hindsight, or if you've done it before, but you shift that many bits and AND 1, and that will tell you if that bit's turned on or not. Okay. So what we want to do is we want to build that up. And so we're going to start with the 100th item, and then we'll shift and do the 99th item, shift, do the 98th. And that's what this does. It shifts it by 1. So it moves all the bits over by 1. And now I can say, okay, now let's figure out if I'm now doing the 99th bit, I need to check bit 198. And I'm going to XOR those together. So that's essentially what we're doing here. We say get the 100th bit, get the 99th 98th bit, XOR them together, and that will tell you what the 99th bit is. You just do that a bunch of times, and then you have to do it one last time right here, where we say shift 1 last time, and then just check the last bit, because we don't have a -1 bit, right? But we want to get that very last 0th bit. And so we just do it one last time. And then I had a bug, I was counting ones, but we don't actually want ones, we want zeros, we want the safe spaces. So that was a bug in my code. What else did I miss? Oh, I forgot the shifting part, right? As I'm like appending bits, I need to be shifting. This happens a lot, right? When you're like my count zeros, for example, this is a pretty common thing where you say like, oh, figure out if my current bit is turned on, and then shift it turned on or not. In this case, I want to know if it's not turned on, and I increment my count. So there you go. Okay, that was quite a long one, but hopefully you learned some stuff. If you're still here for some reason, you watched all my weird bit stuff trying to remember that thing. These are things I just had to remember. I already have it on my list of like reviewing bit operators, and this one would be a good one to review on, to go over again, to prepare. So that's what I plan on doing. So anyway, thanks everybody. Talk to you later.